Hello, everyone, and welcome back to another math session with us. This is week 6 and day number 11. So we are ending this week off. And as you can see, Andrew Frett, he is back with us. Yeah. So, um, why don't we just hop right into our math session um, on today, unless you have something to say since you have been out for uh, 2 days actually.
Been for how long?
For 2 days because we didn't do one last Friday, and then you wasn't here on Monday to do a lesson.
So last Friday, which was what was last Friday? What was last Friday? Last Friday was the the 25th, right?
E-
No,
last Friday
no,
was,
last Friday.
yeah,
Um, no, last
that was
Friday was the second.
October the 2nd.
Yeah, October 2nd. So on that day, um, I I was pretty what was I doing? I got the news that I was going to Florida on Friday, and so I had to get everything in preparation. I had to get everything situated before I actually traveled to Florida. So that's why I wasn't here for Friday. I do apologize for that. Um, Now, the plan for Friday is still on for today. Um, so for those of you that wasn't here that attended the math virtual lesson on Friday, last Friday, I do apologize for that. But at least you get to listen to Daniel's lesson. On Monday, I was not here. I was in Florida pretty much the whole entire week. Pretty much. Got back Wednesday afternoon from a much needed vacation. Um, I even talked about it. I just had vacation in the past couple of weeks. That was part one of my vacation. Part two is coming up in like 2 more weeks, where I will not be here next Friday. I'm going to go ahead and let y'all know now. I will not be here next Friday because I am taking another vacation. Hopefully, that will be the last vacation unless something's coming up at the last minute until further notice. But I was in Florida for a couple of days, much needed vacation, had a good old time. Now I'm back, re-energized. Um, Kind of like took some time to focus really on myself. Don't have to worry about anything. Um, just really just focusing on myself really during those past couple of days. And as many of you, well, those of you that don't know, is that birthday's coming up in about 2 more weeks. So of course I'll be out during that week. Um, so I know Damian had the was on hold down the fort for the past couple of weeks. I know he has been talking about the rationals and irrationals. I do believe today is his last day wrapping up that lesson before moving on into a new lesson, which is scientific notation, and that won't be until Monday. So So that's for his folks. For my folks, Friday lesson was supposed to be multiply and slash divided integers and graphing in 4 quadrants. Also review for operations with integers. I'm not going to review integers today because I've already reviewed Monday, the last Monday of September. So I kind of did a review on that day. There will be another review on Monday, which will be the final day. Where is it? Oh, Monday will be the final day that I will do review. And then Friday, before I leave, is when we're going to hit fractions and decimals. And then once I come back, it's going to be right after that. So just be on your P's and Q's, please do. So just be ready for my peoples. Just be ready. I kind of want to start my lesson now to go ahead and get this over with. So let's just hop right into this, shall we? I'm gonna go ahead and share my screen real quick. Make sure you have a notebook ready, piece of paper or something. Make sure you have that ready. Make sure you have that on standby or take a picture of one. So, like I said, the last session that I did was adding, subtracting integers. So kind of like recapping, this will count as a review. If I can pull this up real quick, give me a second. So to recap, for adding and subtracting integers, I do believe it is this one. While it is loading, I think there's 3 pages of adding / subtracting integers. All right, so while it is loading, I'm gonna go ahead and tell you the rest of my schedule once I come back from part 2 of vacation. The 26th, which is the day that I get back, again, we're gonna talk about rational numbers. That's where I'm gonna go more into depth of Damian's lesson. He talked about rationals and irrationals for a couple weeks now. Now it's my turn. I'm gonna go more into depth about it. Also going to do multiplying and dividing integers. That Friday of that same week, the day before Halloween, is we're going to talk about adding, subtracting like fractions. Also, with a bonus of unlike fractions. So we're going to talk about like fractions and unlike fractions. And then review, and then we won't get into our new unit, which is powers and roots. And then from there, I mean, it's basically lesson review, lesson review, lesson review, up until next year. I mean, not next year. Well, yeah, next year, because there will be a change of schedule. Because I will be helping him out with his lesson. I do believe Monday, November 30th, I will be helping him out with his lesson. So make sure you pay attention as well. All right, so since technology wants to be a mind of its own, Let me stop share for 1 second. This is kind of why you have a backup, just in case things does not load as it's supposed to. Come on, technology, what is going on? Oh, wrong one. All right, so my virtual lesson, my folder, operated integers. Okay, that's not responding. Okay. Oh, it's not on here. Have fun. All right, so we're just gonna go from here. How do I do this? All right, let me screen share this real quick. I am just a mess. See, this is what happens when you leave for a couple of days and things are not working like it's supposed to. All right, since Smartboard wants to act up today, so today we want to talk about graphing for quadrants. So multiplying integers, multiplying two integers with different signs. The product of two integers with different signs is negative. But if it's the same sign, it's positive. So I think a couple weeks back, when Damian said a negative times a negative equals a positive, or when a negative times a negative is still negative, this is kind of like the same scenario here. A positive times a negative is negative, okay? Negative times a negative equals a positive. It's kind of like the same rule here. So here, example of a positive times a negative. So we have 2 times -6, you get -12, or you get -2 times 6 would equal -12. And same thing with the same sign. So if it's 2 times 6, of course, it's going to be positive 12. -2 times -6 equal 12. I do have some examples, but since my thing is not working, I'm gonna have to just move on. But just know that rule that Damian talked about like a couple of weeks back, when negative times negative equals a positive. Just keep that in mind with when you are multiplying. I think with multiplying and dividing integers, just keep that in mind as well. So I have 3 examples. Hopefully when it's finished, doing its thing, I will show y'all some examples here. Because I have one with the same sign, one with a different sign, and then one with the same thing as well. So we're gonna move right along. Actually, we're not gonna move right along. Make sure you copy this down. I'm gonna give y'all a minute to write all this down. Because it's very important when you are multiplying and dividing integers. And when we get to fractions, again, you have to be on your P's, P's and Q's, because we're going to be doing a whole lot of, especially with adding and subtracting unlike fractions, we're going to do a whole lot of, to see if it's a negative sign or a positive sign. So you got to be on your P's and Q's. So I'm going to give y'all till 7:30, and then I'm moving on to dividing integers. So it is 7:30. I hope you write all this down, or if you have a phone, take a picture of it, do whatever you need to do to copy this down. If you don't have this already, don't you worry. This session will be back. We'll be back. We'll be on our social media later. We'll be on social media tomorrow. I cannot speak today. I'm kind of like talking fast because I'm trying to get everything squeezed in. To dividing integers. I know a different font, right? Yeah. It's not the same font that I use every single time. So with dividing integers, it is basically the exact same thing as multiplying. Dividing integers with a different signs, the quotient of two integers with different signs is negative. So the one that you see in orange is an example. So -10 divided by 5 is -2, or 10 over -5 is -2. Okay, keep that in mind. The correlation of two integers with the same sign is positive. So what, a +2, and that's the same thing as 10 over 5. You simple it down as a 2. So the first example, so -35 over 7 is going to be -5. Now you'll be like, how's it -5? Well, remember that rule. They both have a different side. You got a negative on top and you got a positive on the bottom. Okay. That negative overpowers that positive. Okay. So it's going to be negative. Okay. So 64 over -8. And of course, the answer is 8. Again, if you know your multiplication tables, you got to be on it. But the answer here is going to be -8 because you have a positive 64 on top, but you have a -8 on the bottom. Okay. So it's going to be -8. The correlation of two integers with the same sign is positive. So for example, kind of like the same rule here. So 48 over 12 simplifies down to, I believe, 2. You can't do math in your head. Give me 1 second. I believe it is
4.
4. Positive 4. So that tells you a positive over a positive is what? Is a positive because it has the same sign. -56 over -8 is, no, it's not -64. No way. -8. Okay. I'm sorry, y'all. I'm all over the place. Damian, what's -56 over -8? 7.
7.
It's positive. It's a positive 7. Okay. Don't worry. We make mistakes. We're not perfect. There are days where we're just gone. Our branding is not on it. And mind you that I work today, so an 8-hour shift is, it's pretty tiring. So my brain is not on it like it needs to be. So yes, so 7. So it is going to be positive 7, not a -7. Okay. If you put down -7, it is wrong. If I see a -7, it is wrong. It is 7. Or if I see a -4, it is wrong because you did not follow that signs, that rules. Okay. So the final lesson is graphing in 4 quadrants. Again, and I don't think it's going to load today, so I do apologize for that. On Friday, I mean, not Friday. Monday, I'm gonna go over graphing 4 quadrants as part as a part as a review day. But just know that there are 4 quadrants, okay, in the quarter plane, okay? The top right is 1, and it's kinda like clockwise. So you got 1, 2, 3, 4. So you end up at the bottom right as 4. That is going to be your 4th quadrant. So where the positive and the negative at the bottom, that's your 4th quadrant. Your 1st quadrant is the up towards like the 4, like where this 4 is, and where this basically in this square right here. Think of it as a square, basically. Think of it as a square. Okay. And then you go clockwise. 1, 2, 3, 4. Okay. All right. So I know this is short. I do apologize for that. I, again, I do apologize for that. I just, again, I do apologize for not being here on Friday. And I do apologize for not being here on Monday. But don't you worry, I will play catch up. There's no pun intended. But hopefully on Monday, I will be back on track on Monday. So that is all I have. Again, I do apologize. It is short. No videos today as well. I'm just behind, guys. I'm just behind, and I do apologize for that. I know Damian's been on it. I'm not right now, so I do apologize for that. But like I said, that's going to be it for my lesson. On Monday, we're going to go over graphing 4 quadrants, and then that Friday, before I leave, we are going into our new unit, fractions and decimals, which Damian kind of sort of talked about it since the very beginning, since he talked about repeating decimals. We're going to talk about fractions and decimals. So I'm gonna let Damian take the reins over from here. You muted, by the way.
I always do this every time. So as I was saying, you guys, great lesson, Andrew. Great lesson. 6th graders, I hope you was taking notes and listening and paying close attention. So yeah, that was a very good lesson there. And then what I said not last week, the week before last, about a positive number times a positive number. A positive number times a positive number gives you a positive answer. A negative number times negative answer gets you a positive answer. Negative times negative times negative, it gets you a positive answer. So you guys need to remember that. Write it down somewhere, highlight it so you know, because that is important, because you're going to mess up the problem. Trust me, you're going to mess up the problem. So anyways, with that, I'm not going to go into that. So we are now going to enter into our mid-session break for 5 minutes. And right after our mid-session break, we will come back for my lesson. So we will see you guys back in 5 minutes. Right. Excuse me. All right, now we are now back from our mid-session break, which means now it is my turn with my lesson here. So today, you guys, and I'm so sorry, you guys, I have some terrible lighting on today. But anyways, my eighth graders, we are wrapping up our lesson on rational and irrational numbers today. Because we have been doing this for quite some time now. It's probably now today. It's been 2 weeks since we have been on rational and irrational numbers. So and that's enough with that. So today is the last day, which means it's review day. So get out your notes and make sure you copy down this review down, and also refer back to those notes as well when your teachers will be talking about this. You probably have already learned this already, which is good, but to help you out a little more, here's what I'm doing here. So let me share my screen with all of you, and let's get this started with this review of rational and irrational numbers. So let me share my screen. Okay, let me put this to full screen to where you guys can be able to see this all right. Now, hold on, you guys, I just gotta check something out here. All right, so classifying numbers review. So the first what we have is whole numbers. And here are what whole numbers are. They are numbers that do not need. You see, I highlight it and I'll underline it and I put it in bold print, which means you guys should as well because this is important. Whole numbers are numbers that do not need to be represented with a fraction or decimal. Underline that, fraction or decimal. Also, whole numbers cannot be negative. Whole numbers are not supposed to be negative. So make sure you highlight that, underline that. Cannot be negative because we want our whole numbers to be positive answers only. Now, in other words, whole numbers are the counting numbers and zero. Now, here are some examples of some whole numbers I have here. You have 4, 952, 0, and 73. So make sure you guys remember that these are whole numbers. And you see, they are not negative because whole numbers cannot be negative. They cannot. If they are, you did something wrong. So make sure you go back and check your work. Whole numbers are yes.
I'm sorry. Notice that he underlined fraction or decimals.
Yes.
Okay. Again, to my sixth graders, we will not get to that lesson until next week. So make sure you pay attention to this. Make sure you pay attention to this lesson because we will talk about the real number system where, again, we're going to take a deep dive into this. Also, fractions and decimals. We're going to take a deep dive. He just setting up the blueprint for me, for my lessons. Okay. So make sure y'all pay attention. Make sure y'all write this down. Cannot stress this enough. So that y'all be on the ball. Okay. I just want to say that right there.
All right. Make sure you guys copy this down. Copy this down. All right. Moving on to integers. Now, integers are whole numbers. They are, underline that. I didn't underline it here, but make sure you underline that. And they are opposites. Now, therefore, integers can be negative. Whole numbers cannot, but integers can. And here are some examples of some integers down here that I have. You have 12, 0, -9, and then -810. So copy this down. Integers. They are whole numbers and they are opposites, and they can be negative. So make sure you highlight, underline that. Key terms, important. All right, next we have rational numbers. Now, remember you guys that rational numbers, they are numbers that can be expressed, which means they can be written as a fraction of two integers. And remember this, I have this down again, they can be written as a fraction. Please remember that. And here are some examples of rational numbers. You have 44, 0.12, and you see I have a line over the 12, which means it repeats. It repeats. So just to make it short, just put a line over the top so you do not have to write it out because it goes on forever. There's no need for you to write it out. That's just a waste of time there. So a simple way, repeating decimals, if it's a repeating decimal, just put a line over the top of that number so you know that it repeats. Okay, if you need to write this down and say that this line over the top of this number means it repeats, then do that so you know. And then I have -18/5, which is in a fraction form. And then I have the square root of 6, which equals to 6. And 6 is a whole number. Do you guys remember that lesson there, square roots? I hope you do. So copy this down here. And then we're going to move on to irrational numbers. All right, now we have irrational numbers. They are numbers that cannot be expressed. Underline that, highlight that. They cannot be expressed as a fraction of two integers. And you see I have this down here. Remember this, it cannot be written as a fraction, and it cannot be represented by a terminating or repeating decimal. Do you guys remember these terms here? I talk about this in week 1. You guys should know this by now. Terminating and repeating decimal. And then here are some examples of irrational numbers. You have -4π, and then you have the square root of 3, and that gives you a decimal. It does not give you a whole number, because what times what gives me 3? Nothing. Except just 3 times 1, which is 3, but no, nothing. Doesn't give me no whole number. So it's irrational. And then you guys remember I did an example of the square root of 5. That gives me a decimal. What times what gives me 5? Nothing. So it's irrational. Don't get confused by this. It's not confusing. It's very simple and easy. All right, let's move on to what we have next. How are the types of number related? Now, you see down here, the following diagram shows, and I show you guys this diagram here when I first introduced you guys into rational and irrational numbers. But this diagram, it shows that all whole numbers, please underline this because I did not for you guys, because you guys should already know this. All whole numbers are integers. All whole numbers are integers. I'm gonna say this again for the people in the back. all whole numbers are integers, and all integers are rational numbers. Know it, know it, know it. Then you have numbers that are not rational. They are called irrational. If we go back here to irrational, cannot be expressed as a fraction of two integers, and it cannot be represented by a terminating or repeating decimal. So here's the diagram here, and I believe I'll show you guys this diagram here in a YouTube video this past Monday. Well, not this past, well, yes, this past Monday. And remember, you guys, in the video that it showed you guys what types of numbers will go into these circles, what types of numbers will be considered as rational numbers or integers or whole numbers or irrational numbers. I'll show you guys some examples of numbers here that will go into this diagram. Okay, so copy this diagram down because this will help you a lot. All right, now I have some example problems for you guys. Several. So here we go here. We got the square root of -5. And you guys should know that, of course, it's irrational, but it could be something else as well. So what type of number is the square root of 5? Is it a whole number? Is it an integer? Is it a rational? Or is it irrational? We automatically know that it's irrational. So let's check our answer. So let's check, shall we? Now, the first, let's see, is it a whole number? No, because like I explained earlier, it gives me a decimal. So what times what gives me 5? Nothing. It's not a whole number. So you can automatically cross that out. Okay. What about what was the next choice? Integer? Is it an integer? Let's see. No, because if we go back, we'll say integer. Integers are whole numbers and they're opposites, and they can be negative. So no. Do you guys see any decimals here in these examples? No. So it's not irrational. I mean, it's not integer, excuse me. What about irrational? No. Can the square root of 5 be expressed as a fraction of two integers? No. So our only option left is irrational. So why is it irrational? I'm gonna tell you guys. Let me mark this out. The square root of 5, and copy this down. Copy this down, please do. The square root of 5 is an irrational number because it is the square root of a non-perfect square. Remember, you guys, we discussed this when I cover square roots and cube roots. Square roots of non-perfect squares cannot be expressed as the fraction of two integers. So that's why it's not a whole number. I told you why. It's not an integer. I told you why. I told you why it's not irrational. So it's irrational. Copy this explanation down, please. Because some of you guys think that the square root of 5 is rational. How is it rational? I discussed it with you all. It's not. It cannot be expressed as a fraction of two integers. Like it says down here, cannot be expressed as the fraction of two integers. Square roots of non-perfect squares cannot be expressed as the fraction of two integers. There you go. There's the proof. All right, let's see what our next problem is. What type of number is 1001 and 323? All right, so We need to see, is it a whole number? Is it an integer? Is it rational or irrational? Let's find out together. So, is it a whole number? Let's find out. Yes, it is a whole number. Yes, it is a whole number. And I'm going to tell you why in a minute. B says an integer. Is it an integer? Yes, it is. C says, is it rational? Yes, it is rational. I don't know. I'm just not figuring this out, you guys. This changed colors. Wow, I'm so late with this. But anyways, D, is it irrational? No. Now let me tell you guys why it is this number right here. It's a whole number, it's an integer, and it's a rational number. Let me tell you guys why. So 1001 and 323 is a whole number because it is not negative. Do you see anywhere a negative number? No. And it does not need to be represented with a fraction or decimal. Also, it is an integer and a rational number because here we go again, all whole numbers are integers and rational numbers. Please copy that down. Star it, underline, highlight it, whatever you need to, so you know that whenever you see a problem like this, that you know that all whole numbers are integers and they are also rational. Please know it. Highlight it, underline it, highlight it, underline it. All right, let's see our next problem. Ooh, look at here. We have a fraction. What type of number is 3 2/3? So we gotta see, is it one of these choices below? So let's find out. You guys should know what it should be, but if not, I will tell you. So is it, oops, I just went to the next problem, my bad. Is it a whole number? No, this is not a whole number, and I'm gonna tell you why. Is it an integer? Nope, not an integer. What about, is it rational? Of course it's rational, you guys, of course, because it is in a fraction form. Now, what about irrational? No. Let me tell you guys why it is rational and not these other choices. So 3 2/3 is not a whole number because it needs to be represented with a fraction or decimal. And also for the same reason, it is not an integer because of what I just said. Now, 3 2/3 is a rational number because it can be represented as a fraction of two integers. Is this in a fraction form, you guys? Yes. So it is rational, not irrational, or a whole number, or an integer. I'm probably saying that incorrectly, but whatever. So copy this down, these explanations down, because you will see some types of problems like this, and you will probably need to justify your answer, 8th graders. You will need to know how to justify your answer. So like for this, for example, what type, it may ask you something like this: what type of number is 3 2/3? And you chose C, and you mark off A, B, and D, and it's going to ask you, choose the correct answer and justify your answer. And you need to know how to justify your answer. Why is it not a whole number? Or why is it not an integer? Why is it a rational number? And why is it not an irrational number? You need to justify your answer and no. So that's why, you guys, I am teaching you guys of how you need to solve your work and to justify your answer. Because, like I mentioned earlier into our math sessions, the calculator is not your best friend. It's not. It is not always going to be with you. So you need to know how to do the basics problems yourself. You need to know how to do it. That's why I'm doing this for you guys, to help you improve your math scores. Because I want you guys to succeed in your math class, to do great in them, so you know how to do these types of problems and how to get the correct answer and how to get the wrong answer as well. Why is it not this answer here? Well, you could explain it. You could justify it. You could tell your teacher why it's not this, or why is it this. You can explain it to them. That's why I'm doing this. That's why I'm doing this. So copy this down here, copy this down here. And I believe I got one more problem left. And then I will be finished. So let's move on to our last problem. What type, we got a negative problem here. We got a negative. So what type of number is negative 4/2? Well, let's see. Is it a whole number, an integer, rational, or irrational? Let's find out together, 8th graders and also 6th graders. So is this a whole number? No. What about our integer? Yes. Oops. And then it's irrational because I just showed you guys. And then what about irrational? Nope. No, this is not irrational. And some of you guys are thinking this should be irrational. Well, I'm going to tell you guys why it's not. So let's check. Negative 4/2 is not a whole number because it is negative. You see the negative sign here? So it is not a whole number because whole numbers are supposed to be what? Positive, not negative. Also, it is an integer because it does not need to be represented with a fraction or decimal. And then it is also a rational number because all integers are rational numbers. So this down, and I hope you learn a lot today with this review. These are very simple, you guys, very simple and easy to do. It's not complicated, really. Rational and irrational numbers, they're not, it is not a complicated lesson. To me, it's not. To me, I don't know about Andrew and to all of you guys, but to me, this is a very simple lesson to teach anyone about because it is so simple and easy. It can't get any complicated than this. So I hope you learned something from this lesson here. If not, well, I'm sorry. I'm doing the best I can. Me and Andrew, we are doing the best that we can of teaching you guys these lessons. So I'm pretty much finished. I'm going to stop the share right now. So I hope you guys learned something from those lessons that I'll be teaching you guys. So that's my lesson of rational and irrational numbers. I'm finished. Today's the last day. I'm not going to cover it again. Well, let me stop it right there. You guys will see them again. You guys will see them again, trust me. And then also I will reteach them again at the end of the school year where I will be reviewing everything that I have covered. So this week, I'm done. Next week, I'm moving to something new, which will be scientific notation, that is one of my favorite lessons as rational numbers. So I can't wait to teach you guys that. So I'm done. I'm done with fractional and irrational numbers, and I'm going to hand it over to Andrew when he will do this. So I'm done with it. I'm done.
Yeah, so to my sixth graders, you will hear rationals and irrational numbers again. So you think you can get away of him not talking about rations and irrational numbers? Yeah, think again. Yeah, think again. Um,